Hello, let's wait for a few minutes and we can start. Okay, we are starting the session a few minutes early. As such, no student joins, it's all right if student joins, I can go back to the first question. Okay, you can see it's already solved. Let's repeat it because we have further questions that may follow the same concepts. So let's see this question again. Okay, so this is a MOSFET, right? It's a PNP, NPN, N-channel MOSFET. And how do you notify that? Just because of this arrow over here. Okay, so these are the values given for this transistor. Now we have to find the GM, right? So first note that this is your source. This is your source. This is your drain. So for finding the GM, first you need to find the current, right? So if you can look at this expression, what does this say? IDS is equivalent to K W by L. We assume that the device is in saturation, right? So current will be Kw by 2L VGS minus VTH whole square. Now, if you look at the figure again, what is VG? This is drain, this is source, this will be your gate, right? Now, if you want to find the gate bias, what will you do? You see here, what is this? This is a voltage divider, right? So this voltage divider, R1 and R2 values are used in such a way that to give a particular bias to this gate terminal. So how do you calculate that? You know, by this formula, right? Vg will be R2 divided by R1 plus R2 into VDD. And this will give you 5 volts. So your Vg is 5 volt. Now you have to calculate VGS. Suppose this, if suppose your RL here was here it was grounded, so VGS would have been simply equivalent to 5 volt. But no, that is not the case here, right? You see here, uh, your output is connected to this node, and this node is connected to RL. So your output is across this resistor, and obviously these capacitors. So you have to first calculate what is Vs. And how do you suggest we do that? You have all the values of these resistors and capacitors. If we don't use them because we are doing the DC analysis. Okay, so for DC, if I draw the diagram for DC, it will be like this. Just capacitor will act as open, so it will be R1, will be R1, R2, right? So this voltage you know, right? Now you have to calculate Vs, and you know that current flows from this node to this node. So the device current direction. So if you want to find this voltage Vs, it will be value of your current multiplied by this resistor, right? So now you have to find your IDS that we have solved. So what we will do, we have this expression with us, but we don't know Vs. So Vs again depends on IDS. So if we substitute here, Vs is equivalent to IDS RL, and then we have this expression. In place of IDS, what I will do, IDS will be equivalent to Vs by RL, right? So what I will do is, I will write here Vs by RL. Let me just note where I written this here. So Vs by RL is equivalent to Kw by 2L Vg minus Vs minus Vth whole square. Now we have we know Vg, we know Vth, we know these values. Now only remaining variable is Vs. So if we go on solving this, you have all the values, so you will find it Vs is equivalent to 2 times 4 minus Vs whole square. It's simple math now. you will find the expression coming out to be 2vs square minus 17vs plus 32 is equal to 0. And this is a quadratic equation, second order equation. So it will have two solutions. Now one is 5.7 volt, another is 2.81 volt. Now let's see when Vs is equivalent to 5.7 volt. Okay, and your Vg, calculated Vg is 5 volt. Your Vd is 12 volt. So if I calculate values such as Vds, let it be 6.3 volt, right? And your Vgs will be minus zero point 0.7, right? Now since you know your transistor is NMOS, right? You know that transistor NMOS has a positive threshold voltage. So the transistor denoted by Tx will only turn on if gate voltage, gate to source voltage is positive. So here for Vs equal to 5.7, it's not positive, it's negative. So this is not a possible solution. So another is 2.81, and 2.81 for 2.81, VGS will be positive, right? So your 2.81 is the solution for Vs. Now you have to simply substitute it in your IDS. You can calculate your IDS, but the question is we have to calculate our GM, right? So GM is simply uh, uh, D, how your output current change divided by your input voltage. Once you can, sorry, it was urgent. So your GM is simply how your output current change with respect to your input voltage. Here VGS is your input voltage, IDS is your output current. So this comes out to be equivalent to kW by L, VGS minus, right? So you substitute the values, you will get a GM of 2.38 millisiemens. Okay, or you can write it in, let's say, approximately write 2.4. Okay, so this is how you do these kind of questions for MOSFET. Let's move on. Okay, again, okay. So here again, we have to find V output by V in of the amplifier. Okay, V output. Here, you again see this is your V output. and this is your V input. So I have drawn an equivalent circuit here, right? This is your V output. So you have to find how this voltage, normalized voltage, changes with gain. Actually, it's a normalized. A gain we call it a voltage gain because we have to find a voltage. It's voltage divided by voltage. Voltage gain is V output divided by V input. So simple way is you apply the nodal analysis at this point. So we are not dealing with, we are considering that there are no parasitic capacitances, so we need not to use that. So let's just simply apply the nodal analysis here. Okay, so current direction is in this way. If we say that current direction is in this way, and for R naught, current goes in this way. It is just a convention. Keep in mind that you can use any direction as long as you follow the same rules through overall analysis, right? So KCL at this point, KCL at Vs, so it will be GM coming to inverse equal to V output by RL and V output by R naught. So you will get just see that VGS is here is not directly VGS simply because S is not grounded. So S is the voltage of V output, so it will be VG minus V output. Don't do the mistake here. There is a common mistake while doing the questions. Check for whether it's grounded or not. So here, so this will become GM, VG minus V out, and similarly V out will be taken as common 1 by RL plus 1 by R naught. Again, shuffle the variables, you will get V output in terms of Vg, and the form is given here. Again, LHS, RHS variable change, you will get these values. So now we have to find the magnitude. So your GM we calculated earlier in the first step. So GM is 2.38 millisiemens. RL is given to us as 2 kilo ohm. And now R naught. R naught is R naught is used to what do we say, mimic channeling modulation. Okay, so the value is given by 1 by lambda ID. Suppose I have shown this when we lambda VD, right? This is how you, for example, this IDS naught is current without CLM. Now just multiply it with 1 plus lambda times VD and differentiate IDS divided by this output resistance. Intrinsic, sorry, intrinsic. DIDS by DVD, you will get lambda times IDS naught. And this is equal to GDS. GDS is simply equal to IDS naught. So what you have to do to find this value is first find ID without any channeling modulation, then simply use. So it's shown here. But R naught is reciprocal of GDS. So it will be given by 1 by ID. This is a current when there is no IDS, when there is no CLN from this formula. So you see, you calculate this value, it will come out to be 1.4 milliampere. And your R naught will be given by value of 71 kilo ohm. Now this is your intrinsic output resistance component. Alright. So then again, if we go back to this, 1 second. Last time we have not calculated its value. Let's calculate it. Just right. This is how your formula looks like. Let's substitute the values. 2.38 milli. Okay, so this will be just calculate it. Seventy-three divided by 73 divided by 2. Okay, and we add that 0.5 milli, it will give me plus 2.38. It's around 2.9. Then I will output, where will be input, it's equivalent to 2.89 milli. This is your gain. Let's solve this last time. Okay, let's see. Find find the upper cutoff frequency of the gain of amplifier as shown in the circuit. So note that when you have to find cutoff frequencies, you have to consider capacitances. Right. So let's draw the equivalent circuit. Let's assume let's assume that okay, wait a second. Check. Hmm. Now CGS and CGD are given, so we have to take into these capacitance as well. So this is my CGS. This is C1. This is C2. This is your CL. Second. Right. This is a gate. This will be a drain. So this is CGD. Values are given. Okay, CGD is 2 picofarad and CGS is 10 picofarad. Now we have to find upper cutoff frequency. So we know that this capacitor will be responsible for hello. Am I audible now? So do you want me to repeat anything what I have mentioned in this session? You can turn on your audio if you want to say something or you have questions or anything like that. Okay, you can mention in comments if you have any. Okay. So your this capacitance will be responsible for your lower cutoff frequency. So now the question says we have to find upper cutoff frequency. So either CL, C2 is given as very high, right? C2 is 10 microfarad and CL is 100 picofarad. So if you will apply C2 and CL in series, so what you will get is you will get a capacitance that will be around CL. So in our calculations, we can ignore the C2 and consider only Cl, right? So this is one capacitance we should look for. Another is due to these parasitic capacitances, CGS and CGD. Now we know we studied Miller theorem, right? In last session. What does Miller theorem say? If you have two ports and there is this amplifier, there is some gain, and you have this impedance, let's say impedance of Z. This is port 1, port 2. So you can split it in two impedances, right? So here also, in this question, what do we have is, we have CGD impedance that is connected from gate to drain. And let's just write it here. This is CGS, this is CGD, drain, gate, this is your source, and this is your CL, right? So your CGS, C input from the Miller theorem, what can, how can we write C input? So it will be CGS plus part of CGD 1 minus A, right? What is A? A is your gain. So this will look like you have CGS and there is one more capacitance parallel, CGD. That is this one, right? Part of CGD dash. That is CGD 1 minus A. So this become parallel. So we can write C in total as CGS plus CGD times 1 minus A. Okay. So therefore total C in will be CGS. CGS is 10 picofarad. The CGT is 2 picofarad. 1 minus what is gain? We calculated gain, right? Gain was 0.82. This is magnitude. So in, you know, in amplifier it will be minus, right? So it will be minus times minus 0.82. So we will get 10 picofarad plus 2 picofarad, 1.82. One second. Uh, Week 8, yes. These were the questions from week 7, which by the limitation of time couldn't be completed. We have these two questions and then we have week 8 as well. 1 second. Let me just check. No, this is week 7, right? This is not week 8. Oh, week 8 will be in next session, next Tuesday. This is week 7 today. So have you gone through week 7? So these are the questions related to week 7. After 15, there will be more that will be more specific to week 7. These are few questions that are from week 6 that were not completed in the previous session. Okay, you have doubts. I have not looked at week 8 yet. We have a discussion session next week. You can join then next week, I think. Or if you have general questions, you can ask, but I have not gone through week 8 yet, the content which we have to cover in week 8. So this is actually the session related to week 7 only. If you have some general question, you can ask. Maybe I will be able to answer. Should I continue? Okay. So where were we? Okay, upper cutoff frequency. So if you have gone through the sessions, I told you how we derive these formula. You have to just remember. Let me just write it for you here. Wait a second. Okay. So as I told you, first actually, what you should do, the simple formula we have is like this, right? If you want to find upper cutoff frequencies, you have to look for two frequencies. Two capacitances. One output capacitance and another is effective input capacitance. That is because of your parastics. Okay. So if you have output capacitance denoted by, let's say, CO, you have to find R output first. What is R output? And then you have output capacitance. This will give you one frequency. Another will be 1 divided by 2 pi. This is your effective input capacitance, and you find R effective input as well. I will just show you from the one example from the circuit, and this is seen. Let's say uh, if you want to do these questions, just do these steps. Let's say this is R1, this is here C in, this is your gate, this is your source, this is a common source, right? If you want to do these questions easily, this is I think the most easiest method to do these questions. Is this circuit okay? Can you see the circuit? Okay, let me just show you. So, if you want to find the lower cutoff frequencies, do this step. Remove these capacitances, okay, and then simply find what is R here, right? What is simply R here? Once you find R, then your F becomes simply 1 by 2 pi. Let's say this will be R in into C1. Similarly, if you want to find uh, with respect to this capacitance, again, you short these capacitance in series, you find this, you have the capacitance in hand, then you find the total resistance. If there is some resistance here, you add them, you will get F2, 1 by 2 pi, this is R1, and if there is only R1, then it will be R1 into C. And similarly for C output, find again R output, you short the source, short the capacitance here, so you will find F3 is 1 by 2 pi C output R. So this is how you find it actually. The more detailed derivation is given in previous sessions. You can always look back. So here in this question, what we have to do is let's calculate this value first. This is 2 into 1.2 plus 10. That is 13.64. 13.64 picofarad. Right? This is our C in. Okay. So we have calculated C in. What we have to calculate actually is upper cutoff frequency, right? Now we have to find the resistance as well. Now look here. Uh, this is your resistance Rx, let's say, across this input capacitance, right? So you will get it as equivalent to R1 parallel R2 because there is nothing else connected. So one frequency you will simply get as 1 by 2 pi R1 parallel R2 C in, right? Now again we have output as well. So this is F in, this is F output. We will get, this is simply equal to, if you look at this figure, it will be simply RL. So this will be simply RL CL. Sorry, yeah, this one. So this is how you will calculate it. Oh, wait a second. Okay, sorry, sorry. Now we have to again give some time over here. We have to calculate the output resistance first. Let me write it. This is R out. Let's calculate first. F1 in, that will be simply 2 pi, and R1 parallel R2. R1 is second. Okay. So this is R1 is 5 kilo ohm, R2 is 5 kilo ohm. So it will be 2.5 kilo ohm. That is 2.5 kilo ohm. And C input we calculated just in previous step as 13.64 picofarad. Right? So this will be 1 divided by 5 pi into 10 is power 3 into 13.64 into 10 is power minus 12. That will be simply equivalent to 10 is power 9 divided by 5 pi into 13.64. Let me just use the calculator. 1 divided by 5 divided by 3.14 divided by 13.64 comes out to be 4 gigahertz approximately. Right? This is one frequency. Now let's calculate another one. First, we have to find R out, right? Let's look at the circuit. Okay, just 1 second. Let me just try to copy it. One more time. Oh no, leave. Still new to this. Let me just draw here. Okay, as you can draw this quickly. So ground, this is how it will look, right? So your VG is 0, but your Vs is equal to Vx. So if you look at this node, it will be, apply a KCL here. So it will be Ix coming here will be equal to Vx by RL minus GM. Gs, that will be Ix plus, 1 second. Okay, Vx by RL plus GMVS, and your Vs is Vx. So your Ix is equivalent to Vx by RL plus GMVx, right? So there was R naught as well. Let's just check. Oh, sorry. There is R naught as well. So we cannot ignore R naught. Okay. Let's just R naught, we calculated R naught as 71K. How did we forget that? We can just simply add here R naught 2. So it will be, let's say the current goes in this direction. So it will be Vx by R naught as well. So it's simply Vx by R naught. It will be Vx by R naught. Oh, one more page, please. Right? So your R naught, Rx, sorry, your R out will be equivalent to Vx by Ix. That comes out to be 1 by RL Gm plus 1 by Rf plus 1 by R naught, right? So this is your R out. So now upper cutoff frequency or second frequency will be as written over here, that is 1 by 2 pi R out CL. Let's first calculate what is the value of this R out. Gm, you know, Gm, we calculated Gm in previous step. Suppose we calculated it as well. Let's just see what was the value. I will take value from this here. Let me just see 73 divided by 71 divided by 2.89 milli. So this is 2.8. Suppose there is something wrong here. Vx by ix. Sorry, it should be minus 1. This is inverse. Vx by ix is 1 by gm plus. So it will be 1 divided by 2.89 milli. So that will be 1000 divided by 2. It's 346 ohm, right? So it will be 2 pi into 346 into CL. What is CL now? That is 100 picofarad. That is 100 picofarad, right? Let's just calculate it. That will be 10 is power 10 divided by 2 pi into 346. That is 1 divided by 2 divided by 3.14 divided by 6. That is, okay, 4 into 10 is power minus 4 into 10 is power 10. That is 46. That's 4.6. That will be 4.6 into 10 to 6. That is 4.6 gigahertz. So we have to take minimum of the two. Minimum of the two, this is 4 gigahertz. So our cutoff frequency will be 4 gigahertz. So we did two things in this. One, we found how to find the output resistance again, and then two cutoff frequencies. And we observe which one is the minimum among them, and that is your upper cutoff frequency. Right? So can I suppose there anything else in this question? No. Sorry. I have written one thing wrong. Please pardon me for this. This is megahertz. Sorry. This is megahertz. So cutoff frequency will be 4 megahertz. Okay, now coming to this part. These are questions that are related to week 7, right? So how we are doing these sessions is we do some questions from the previous week, and then that summarizes and that gives an idea about what we read in the previous week and then follow with the next week. So it covers two things at the same time. So it will be good for you as well to remember the previous sessions and remember the previous topics as well. So let's see what does this question say. Okay, this is again questions on MOSFET. Here, if it is not given as well, there is an arrow here to note that there is a PMOS. Okay, so the values are given for the device. Also note that the parasitic capacitance values are also given. So while doing the question, you should not ignore these. Okay, so this is a current driven device. Okay, find the value of, so this is the question, right? Find the value of small signal parameter output resistance RDS. We have to find RDS, or which we note by R naught, right? So how do we calculate RDS, R naught? That is 1 by lambda I. Here it's a PMOS, so I will write ISD. Right. So the current will flow from, first let's see which is source, which is drain. So for PMOS, this will be your applied voltage and this is your source. This is your drain and this is your gate, right? So first you have to find ISD, right? This gate voltage, you know, how we can calculate the gate voltage? Again, this is a voltage divider, right? So your VG will be R2 divided by R1 plus R2 into VDD. That is what VG will be equal to R2, that is 20 kilo ohm, divided by R1 plus R2, that is 40 plus 20, 60K into 12. That is 4 volt. That is 4 volt. So your VG is given to us. Now we have to calculate again Vs, right? So if we go by the formula again, the ISD will be equivalent to 12 VSG minus VTH whole square. This we know, this we also know where to find Vs. And if we look at the picture again, so can we find, is there any other way where we can use this node? Yes. If you use the KVL or directly current current across resistor RS1, How can we write it? There are two nodes. Here it is at VDD, it is at VS. So I can directly write current. And the current, what is the current that flows through the resistor? ISD, that is the device current, right? Here it's capacitor, so all the current will flow from this node to this node, not through here, right? So it will be simply what ISD will be simply VDD minus Vs divided by Rs1, right? So can you substitute it here in 1? So we can write it as VDD minus Vs divided by Rs1 is equivalent to Kw by 2L Vs minus Vg minus mod Vth whole square. You have all the values, you have these values. When you put these values, you will get an equation of this form. This is simple quadratic equation. You solve you change the variables from LHS to LHS, LHS to RHS, you will get this equation. And obviously there are two solutions, and you will note that this is the voltage which will be the only solution, right? So your ISD will be simply equivalent to VDD minus Vs by Rs1. And you substitute the values, you will get a current of 2.68 milliampere. Substitute it here. VDD is known to you as 12 volt. Rs is also known. No, this is a sorry milliampere. Now this is your drain current. Now can you find your output resistance? Yes, that is R naught is equal to 1 by lambda times I S D. What is lambda? 0.01. That is 10 is per minus 2 into 2.68 to 10 is per minus 3. That will be equal to 10 into 10 is power 4 divided by 2.68. So your R naught, let me just divide it, 10 divided by 2.68, that is 37.3 kilo ohm. This is your 37.3. This should be the answer. Okay. Now, if we are done with this, okay, so we can move on to another part. And now we have to find gain here. But look here, this is V output by I in. So this is voltage to current gain. Give me a moment. So this is voltage to current gain. I in is given in the figure, right? And there is a hint given to us how to solve this question. It says that first find AI, that is current gain, to be given by I output by I input, and then find voltage gain as AI into R out, where R out is the output resistance. So let's just see how we can find it. Again, we will need equivalent circuit. So first, let me draw equivalent circuit quickly to find R out, R out, right? So this is your circuit, and your output is at drain here. Huh? This is a PMOS, this is a drain. So let me just draw the equivalent circuit for our output. Fine. So you cannot ignore these resistances. So you have to take these as well. So this is here open. Okay. So this is your V source. This is ground. Ground is sorry. This is gate. Gate is grounded. So you have to calculate now R out. This is the first step to do. Find R out. So now if you look for the values of RS, RS is given to you as 100 kilo ohm and RS1 is 2 kilo ohm. So if these are in parallel, we can ignore RS, so we can treat only RS1 to simplify our calculations. So let's see. Let's do it from okay. So let's add a test source here, VXIX, right? So if I apply here the KCL, what I will get is Ix is equivalent to Vx by R naught plus Gm Vgs, right? And your Vs. Now look here, if current I supply a current of Ix here through this node, part of it flows through this line and part of it will flow through the R naught. And here by the conservation of charge, so there should be Ix here, right? So current going in should come out as well. So Vs will be simply equal to Ix Rs1. So my Ix is equivalent to Vx by R naught plus Gm times Vg is 0. Let me just write for time being Vs. Vs is S1. So this will be Vg is equal to 0, it will be Ix plus Gm times Ix Rs1 is equal to Vx by R naught. So my Ix will be taken as a common, so it will be 1 plus Gm Rs1 is equal to Vx by R naught. So my R out will be simply equivalent to R naught divided by, sorry, not divided by, is 1 plus Gm Rs1. Let me cross check R out. Let me cross check with R out. Okay, I think I have done mistakes somewhere. Okay, wait a second. Ix. Okay, one second. Right, here is the mistake. This should be Vx minus Vs by R naught. This is your Vs by R naught. So it will be Vx by R naught plus, sorry, not plus. This is minus Ix Rs1 by R naught, right? So this will be actually Ix. Let me just clear this. So this should be Ix1 plus GMRS1 plus RS1 by R naught is equivalent to Vx by R naught. So I suppose Vx by Ix, that is your R out, is equivalent to R naught. You multiply it both sides, so we will get R naught plus RS1 plus GM R naught RS1, right? More simplified, if you want to write it in more simplified way, so you can write it as R out is equivalent to RS1 plus R naught 1 plus GM RS1. This is called as source degenerated load. You substitute the values, you will get, RS1, R naught, GM and RS1 again, so you will get a value of 2k ohm. And then your total R out is this 2k ohm parallel to RD. So what is the value of RD? RD is 2k. Okay, so this will be a 1k. So R out is, it will come out to be 1k. So now your voltage gain we output by I in. is equivalent to AI or that is your total. Now you have to find AI. Okay, let's move to AI. That is I out by I in. Let's see. We'll do this here again. This is grounded. RS1, I said earlier, RS is very high. GMGS, this is R naught. This is your R naught. This is RD, and this is your I out. Okay, so the goal is to calculate I out by I output by I in, right? So now we have to apply KCL, right? So applying KCL at this node. Let's assume it node X. So your I in will go inwards, and again it's current of GM VGS is equivalent to, now current will go in this direction. This is Vs, so it will be Vs by Rs1. One second, right? And again the current from here to here. That is Vs by R naught. Since it's grounded, so it is simply Vs. So we can write it as I in is equivalent to Vs 1 by Rs1 plus 1 by R naught minus Gm Vg minus Vs. Now look here, Vg is again attached to ground. So the I in will be simply equal, it will become positive. So I can take Vs as common. So Rs1 plus R naught plus Gm, right? So this is your I in terms of Vs. Now next step is to calculate I out. So now we will apply KCL at this node. Let's call it node Y. At node Y. So it will be I out going outwards, and you have GMVGS going again outwards, right? And you have ground here, so it's Vs, it will current will come inwards, so it will be Vs by R naught. So you solve this, you will get I output is equivalent to Vs Gm plus 1 by R naught, right? So next step is to calculate I output by I in. Now you have both the equations. One second. Now you have equation number one, you have equation number two. So you just divide 2 by, 1. You will get I output by I in, because Vs will get cancelled, so what will remain is Gm plus 1 by R naught, and in denominator it will be 1 by this term, that is 1 by Rs1 plus 1 by R naught plus Gm. Okay, so this is your AI, right? So now you know the value of Gm, you know the value of R naught. We have calculated it, and you can now just directly calculate AI. Then you will be able to calculate voltage to current gain as well. So this is how you will get your answer. Please do the calculation. If you want to know the answer, please do comment and I will post the answer as well. Okay, so this is the question that states that we have to find cutoff frequency. I will go quickly for this question as we have already gone a lot of times to calculate these kind of things. So if I just draw the equivalent circuit, I have drawn it here, so I will just directly draw the circuit. This is your equivalent circuit. Give me 1 second. All right. So this is your CGD, this is your CGS. Now you have to find the cutoff frequency. So you have multiple frequency components, right? Let's take one. One will be, if this is your output, so you have to find this resistance. Simply 2 pi R out, and we have already found the what is R out, right? So this should be 1 1. Frequency will be given by this. We know this value. We know this CL. Please put the values in it and find it. And next one is due to this input capacitance. And what we have to do is you have to use Miller theorem for this capacitance. And then at the CGS, then you will find another frequency. So you have to open these components, and then you will get an input effective capacitance, right? Then you have here resistance one, resistance, but okay. So again, this will be grounded, so this is grounded, and then but this won't take a part, this won't take any part here, so we're left with RS1 parallel RS. So you have to find another frequency through this RC network. So another frequency will be given by F2 will be given by 1 by 2 pi RS1 parallel RS multiplied by C in. You know how to calculate C in, that is C in will be CGS plus CGP 1 minus A, right? Please do remember this. Alright, so remember this formula, it's important to calculate this. And minimum of these two, F1 and F2, will give you upper cutoff frequency. So now we are done with this. Let's move on. Okay, so this question is this is a two-stage question. This is again PMOS. This is common source stage, and this is common drain stage, right? Now what we have to do is we have to find V output. V output, that is the source voltage of second transistor. So let's start first. So first we will find VG1, that will be simply given by R2 divided by R1 plus R2 VDD, and that is given to us as 12. You find the value, that's 12K divided by 4K plus 12K into 12, you will get it is equal to 9 volt, right? So this is 9 volt. And here source is 12, so it has a VSG of 3 volt. So this is all good. So first we will find ISD here, then we will take this voltage as a gate voltage for second transistor. So ISD1 will be equivalent to kW by 2L VSG minus VTHP whole square. So this is 1 milli. kW by L is given by 1 milli by 2. VSG we calculate as 3 volt minus 1 whole square. So we'll get it equivalent to 2 milliampere, right? So your current is 2 milliampere. So your VG2 is simply IST1 into R3, that is equivalent to 2 milliampere multiplied by R3 is 4 kilo ohm, that is 8 volt. Now you have to calculate Vs, right? So you have to calculate ISD2, that is again given by kW by 2L VSG minus VTH whole square, sorry, not whole square. And also it is given by VDD minus Vs by R4. Again, can you see that this is equivalent to Vs minus Vg? You know Vg, but you don't know Vs. But in these two equations can be solved to give a quadratic equation. And when we do that, we will get an equation of form Vs2 square minus 16 Vs2. We write it as Vs2 here. Plus 51 equivalent to 0. Solve this question please, and you will get a value for Vs2 as 10.65 volt. Now that was the question that we had to calculate V output, and V output is and this is simply equal to V output, which is again 5 volt. So this is your DC output voltage. Moving on, now we have to find small signal output resistance of the amplifier. That we know, small signal output resistance. One second. Right. So now we have to find output resistance. Let's just quickly draw the equivalent circuit. We have here gate, we have here source, GM, VGS. The first transistor, this is R3. This is gate for the second transistor. This is your R4. This is your GM, VGS2. This is your ground. And since this is your V output, so we will add we'll add a test source here. So what we will get is okay, so you add this will be GM VGS2 plus IX is equivalent to VX by R4. So you will get GM, it is simply VG minus, this is minus times VX plus IX is equal to VX by R4. So it will simply be equal to Ix is equal to Vx times Gm plus 1 by R4, right? So your R is simply equal to 1 by Gm, sorry, R4 divided by Gm R4 plus 1. So this is your output resistance, and you go on calculating it. If I just directly to say time, this is Gm2. Gm2 comes out to be equivalent to Kw Vsg minus Vth by L, right? Substitute the values, it is 1 milli, and we calculated the previous values as well, so it will come out to be 1.65 millisiemens. Okay, let me just put the values. R4 is 1K divided by 1.65 milli into 1K plus 1, we'll get it to 1.265, that is 377 ohm. This is your answer for this question. Next is we have to find V output by V in. Alright, in the mid-frequency range, and we know in mid-frequency range you just do the small signal analysis you do for the rest of the questions, right? Let us just look here. We can directly write the output as GM times, or if we say this has a gain of AV1, this is a gain of AV2, so my total gain will be AV1 into AV2. This you know, right? So here also we can find AV1 multiply AV2, right? So AV2 is simply equivalent to GM2 times R4, right? This GM2 times R4. This is your gain, right? And your AV1 is GM1 times VG1, right? Let me just check. G1, right? But your VG1, if we look here at the diagram, your VG1, okay, 1 second, V in, think I suppose I should not write it in this way. Okay, so for first transistor A1, AB1, we can directly write from this equivalent circuit. Do we have the equivalent circuit here? If I just agree for reference. Okay, so VG1 is directly equal to V in. VG1 is directly equal to V in, right? Okay, and then we have to find V out. Okay, so again, now V for second transistor, you have V output is equivalent to GM2 times R4 into VGS2, right? And this gives me R4. We know VS2 is again V output. So we will get V output plus GM2 R4 V output is equivalent to GM2 R4. So you will get a V output of GM2 R4 divided by 1 plus GM2 R4, and this is VG2. This is VG2.